We've seen the natural logarithm function. There are other logarithm functions as well. Let's define them. First, let's remember facts about the natural logarithm. So the first fact is that natural log x and e to the x are inverses. They undo each other. And graphically, inverse functions have a graph that's similar to the graph of the regular function reflected about the line y equals x. The graph of log x can therefore be found. The graph of log x has a 0 at x equals 1, a vertical asymptote at 0, grows quickly if you're close to 0, but after 1 grows slowly, very slowly actually. If you plug in e is approximately 2.71 and so on. Log of e is 1 because log and e are inverses. They undo each other and you'll just get back 1 here. And there's a graph of log x. A second property is that log turns multiplication into addition. So log of a times b is log of a plus log of b. The third property is log of a to the n power. That's equal to n log a, and that works for any n you'd like. Okay, so let's define a new logarithm. We let log spelled out, so the natural logarithm is usually abbreviated ln. The natural logarithm is spelled out log, and it sometimes has a base here, a. So this log base a of x is nothing more than the natural log of function divided by log of a. So natural log x divided by natural log a. The natural log function has domain, all positive numbers. You can't plug in a negative or 0 into log. So this means the a value has to be a positive number. Let's do some examples. So log base 2 of 16, what is this? Well, if you just write down what log base 2 means, this is natural log of 16 divided by natural log of 2. That's the answer, but I'm going to simplify this a little bit using the observation that 16 is 2 times 2 times 2 times 2. So 16 is 2 to the 4th power, and that's divided by log 2. I could use property 3 that I wrote down here and say that this is equal to 4 log 2 divided by log 2. Now I can cancel the log 2 and I just get 4. So log base 2, 16 is 4. Let's do another one. What if I did log base 10 of 7? So log base 10 of 7 is the same as natural log 7 divided by natural log 10. Now, this one won't simplify and give you a nice simple answer such as 4. You could type it into a calculator or a computer, and you can approximate, though. You get about 0.845 and so on. Here's the key fact about log base a. If you define log base a in this way, then a to the x power and log base a of x are inverses. That means they undo each other. Let me show you why. It's actually not that hard to see. If I do log base a of a to the x power, log base a means do natural log x divided by natural log a. So this is natural log a to the x divided by natural log a. Using property 3 of these exponent rules here, I got x log a divided by log a. Log a's cancel. You just get back x. So that means if I put one function inside the other, they cancel each other out. They're inverses. I just get back x. And you could show that the reverse composition also gives you just back x. So a to the x and log base a of x undo each other. They're inverses. Let's finish this video with one example. How about if I ask to simplify log base 2 of x plus 1 minus log base 2 of x minus 1. In my example here, I use log base 2 and log base 10. Log base a is defined for any positive value of a, but the most common bases you'll see are 2 and 10. Additionally, natural logarithm can really be written as log base e. Actually, before I do this example, I just want to notice that if I do log base e of x, I get natural log x divided by natural log e. Natural log of e is 1, so this is just natural log x. So the three most common bases, I guess, for a logarithm are e, which is the natural log, 2, and 10, and maybe sometimes 16. Okay, so let's simplify this. Before I do that, maybe I should find the domain of this function. So this is a function of x, the domain. I can't stick in a negative number into a logarithm. I can only stick in a positive number. So that means I need x plus 1 to be positive and x minus 1 to also be positive. That says x has to be bigger than negative 1 and x has to be bigger than 1. Both of these conditions have to be true. If this condition is true, if x is bigger than 1, then this condition is automatically true. So the domain is all numbers x bigger than 1. So anyway, back to simplifying. This is natural log x plus 1 divided by natural log 2 minus natural log x minus 1 over natural log 2. I can factor out 1 over log 2. 1 over log 2 is just some constant. It's just some number. Then I have a difference here. The difference I can do the following with. I could say this is log x plus 1 plus log of 1 over x minus 1. I turned the minus 1 in front here into a negative 1 exponent. And a negative 1 exponent is the same as division. Then I can use property 2 on this list up here and write this in final form as log of x plus 1 over x minus 1 divided by log 2. So there's my final answer. If you want, you could still write this in log base 2. So this is log base 2 of x plus 1 over x minus 1. And what I'm trying to illustrate with this example is that property 2 and property 3 still hold true for log base a. Okay, so there's a very brief introduction into logs with other bases than the natural log. Wonderful.